The sun, how our star powers everything in the solar system. There is a force so powerful that every single second is unleashes more energy than on Earth humanity could possibly consume in millions of years. Imagine it. In the blink of an eye, our sun radiates enough power to light up every city on Earth, dry every engine head, every home, and fuel every living creatures across the planet. For an unfathomable stretch of time, it paints our skies in brilliant blues and fiery oranges at dawn and dusk. It dries the fierce winds that whip across vast continents, sculpting deserts and pushing sailboats across oceans. It fuels the mighty currents of our seas, which in turn regulate our global climate, keeping hurricanes at bay or unleashing them in fury. And most profoundly, it fits every single living thing on Earth. From the tiniest microbe in the soil of the Midwest prairies to the massive blue whales gliding through the depths of the Atlantic. And that the colossal powerhouse exists at a distance that defies human comprehension, roughly 150 million kilometers away. That's like circling the Earth more than 3,700 times, too far to touch, too immense to control, and that's so perfectly positioned that its gentle rays reach Earth that night. Without it, our world would be a frozen, lifeless rock tumbling through the void. This is the story of the sun, not just a bright that's hanging in the sky on a lazy summer afternoon, not merely the object we squint at during an eclipse or taste with solar features on our telescopes. No, it is the invisible engine behind everything we know, everything we are, and everything we will ever become. From the food on the table to the air you breathe, from the ancient fossils buried deep underground to the modern solar panels glinting on rooftops. The sun is the ultimate source. It is the heartbeat of our solar system, the architect of life, and the silent guardian of our fragile existence. Join me as we journey into its fiery heart, across its invisible wings, and through the delicate balance that makes Earth the only home we have ever known. If the sun were to suddenly vanish from our skies, poof, gone in this instant, nothing truly catastrophic or strike in the first few seconds. The sky would plunge into an eerie, star-filled darkness, but life would carry on, blissfully unaware of a fleeting moment. Birds might still sing their morning songs out of habit. Cars would keep rolling on highways it lit only by headlights. People would pause, confused, taking their phones for news of some global blackout. But then, slowly, inexorably, everything would begin to collapse. Within hours, the first hints of trouble would appear. Global temperatures would start to plummet as the planet's surface loses its primary heat source. Within days, the drop would become noticeable. Frost forming on tropical lakes in the Amazon, ice crystals remain rivers that never froze before. Within weeks, the two horrors would unfold. Plant life, the very foundation of nearly every food chain on Earth, would begin to wither and die. Photosynthesis, the miraculous process where green leaves capture sunlight and convert it into chemical energy, would grind to a halt. No more sugar produced, no more oxygen released into the air we breathe. Forests would turn brown and brittle, grasslands would yellow and crumble, algae in the oceans, responsible for more than half the planet's oxygen, would starve in the gloom. And when the plants die, everything that depends on them follows in a cascading domino effect. Herbivores like deer and cattle on the Great Plains would weaken and perish first. Predators, lions in the savannas, goats in Yellowstone, eagles soaring above the Rockies would face starvation soon after. Insects that pollinate our crops and would vanish, collapsing agriculture. Even the mighty oceans would suffer as plankton populations crush, starving fish and whales alike. Humans, with our stored food and technology, might last longer, perhaps months or years, behind fortified walls, but eventually the chain would reach Earth too. No sunlight means no new energy involving the system. We are all, at our core, sunlight eaters. Picture that vivid scene in your mind deep in the Amazon rainforest. A single golden beam of sunlight pierces the thick canopy and lands delicately on a broad green leaf. That photon, tiny packet of energy born in the sun's core, triggers a cascade. Chlorophyll molecules absorb it. Electrons jump into excited states, and through complex dance of chemistry, carbon dioxide from the air and water from the roots are transformed into glucose and oxygen. That stored energy then fuels a tiny caterpillar mounting the leaf. The caterpillar becomes land for a color bird. The bird sustains a stealthy snake, and higher up the chain, perhaps a joker or even an intelligent hunter in the rainforest relies on that same spark. A complete, thriving ecosystem empowered by 100 rays of sunlight traveling 150 million kilometers in just over 8 million minutes. The hidden truth of life on Earth. Almost every form of energy we use, directly or indirectly, traces its origins back to the sun. Think about it. The electricity powering your lives right now might come from solar panels on a distant farm in California, or from hydroelectric dams along the Mississippi River, where sunlight evaporated water falls as rain and turns turbines. Even the fossil fuels we still burn so heavily, coal, oil, natural gas, are nothing more than ancient sunlight. Captured by prehistoric plants and plankton buried under layers of earth for hundreds of millions of years, and now dug off to release that trapped energy in our cars and power plants across the Midwest. Wind energy. Sunlight hits the atmosphere unevenly, creating pressure differences that drive the winds sweeping across the Great Plains. Ocean waves driven by those same winds along the Pacific coast. Even the food you ate today, whether a juicy apple from Washington Orchids or a steak from grass-fed cattle in Texas, Texas started with photosynthesis. The sun is not just part of nature, it is the origin of what we call nature itself. Without a steady, reliable output, our blue planet would be barren at the moon, cold, dark, and eternally silent. Every breath you take, every step you walk, every dream you chase, under the stars, it is a direct descendant of that distant nuclear furnace. We are our very existence to it. At its core, the sun is not some ordinary fire like the logs cracking in your fireplace on a winter night. No, it is something infinitely more powerful, more elegant, and more enduring. A nuclear engine driven by the process known as nuclear fusion. Deep inside the sun's core, where pressures are unimaginable and temperatures soar to around 15 million degrees Celsius. With hydrogen atom, the lightest and most abundant element in the universe, are crammed together with such furious force that they overcome their natural repulsion. Protons smash into one another, fuse, and transform into helium. In that split second acme, a tiny fraction of many a match simply diseases. And in its place, pure energy erupts. For according to Einstein's famous equation, equals mc squared. Mass energy equivalence as more spectacular. Every single second, the sun converts approximately 620 million tons of hydrogen into about 616 million tons of them. That missing 4 million tons, it doesn't vanish into nothing. It becomes energy enough to power the entire solar system for billions of years to come. The energy doesn't burst out there instantly like an interior. Instead, it begins a long tortuous journey outward through their sun's layered interior. First, the radiative zone, where photons pass around like pinballs in a chaotic game, taking anywhere from 100,000 to 200,000 superheater. There are huge plumes of superheated plasma that rise and fall like boiling soup in a giant pot, carrying the energy of the final distance to the photosphere, the visible surface we see from Earth. But here's something most people don't realize, something that adds a layer of almost poetic wonder to every sunny day. The sunlight you feel warming your skin today, the rays that make your shadow stretch long across the grass in Central Park. The light may have started its journey to not yesterday, not last week, but tens or 1100s of thousands of years ago inside the sun's surface. It has been recalculating, scattering, and slowly migrating through dense plasma the entire time. Then, finally free, it races across the vacuum of space at 300,000 kilometers per second. A journey spanning eons inside the star, followed by a cosmic spring that ends at a gentle caress on your face, or the sparkle in a child's eyes as they play outside. The fusion process is self-regulating too. The sun has been doing this steadily for about 4.6 billion years and has enough hydrogen left in its core to continue for another 10 billion. Has enough hydrogen left in its core to continue for another 5 billion or so. Eventually, it will run low on fuel, swell into red giant, and perhaps engulf the inner planets before shedding its outer layers and becoming a white dwarf. But for now, in this golden age of our solar system, it burns with perfect constancy, giving us the stable light and heat the allowed life to everyone and try across the America and beyond. The sun does not end roughly at its visible surface. The photosphere, far from it, the sun extends its influence across the entire solar system and beyond through a constant, invisible stream known as the solar wind, a relentless outflow of charged particles, mostly electrons and protons, laced with magnetic fields. Have you ever looked up at a clear night sky over the Grand Canyon and wondered why comets always seem to have those glowing tails streaming away from the sun? No matter which direction they are traveling, or why astronauts on the International Space Station sometimes have to take extra precautions during certain space weather alerts. The answer lies right here in the solar wind. The wind plucks outward from the sun's corona the ultra-hot outer atmosphere, visible only during total solar eclipses. A speed ranging from 250 to 800 kilometers per second, that's far enough to circle the Earth in under 2 minutes. It carries not just particles but energy and magnetism, carving out a vast protective bubble around our solar system called the heliosphere. In a very real sense, the sun is touching every planet, every moon, every comet, and even the empty space between them. Space is not a vacuum in the truest sense. It is alive with the breath of our star. Let's bring it closer to home with something you might experience every day. Think about your smartphone's GPS navigation. On a normal drive along Route 66 or a hike in the Rocky Mountains, it works flawlessly. But during a strong solar wind event, when the sun is particularly active, charged particles can interfere with satellite signals, causing your map to glitch or your location to zoom unexpectedly. Pilots flying long-haul routes over the poles have reported similar issues with radio communication, and for space enthusiasts. Remember the Parker Solar Probe? The NASA spacecraft has flown closer to the sun than any human-made object ever has, driving straight into the solar wind to study it up close. It sounds backdated, showing how the particles can accelerate to incredibly speeds, sometimes creating space hurricanes that squirrel around Earth's magnetic poles. The solar wind shapes growth in profound ways as comet tails pushing dust and gas away from the sun like a cosmic hairdryer. Exactly why Halley's Comet or the recent comet to Sujin Sun 80 alert always point that they are tails away, even when heading back out to the distant edges of our solar system. It interacts with planetary atmospheres, sometimes stripping them away over eons, sometimes creating beautiful light shows. Voyager 1 and 2, our farthest flung spacecraft, finally crossed the heliopause, the edge of the sun's fluorescent influence. Decades after launch, entering through interstellar space and sending back data that still amaze scientists today. Closer still, the solar wind even affects Earth own weather patterns indirectly by influencing cosmic rays that reach our atmosphere. The wind is not uniform either. It varies with the sun's 11th-year activity cycle, growing stronger and more turbulent during solar maximum when sunspots and flares erupt. Fast and slow streams collide, creating shock waves that ripple through the system. And on it, every particle, every fluid light originates from the sun's dynamic outer layers, coronal hosts, active regions, and the ever present plasma dance. So the next time you feel you feel sudden static shock when touching a doorknob on a dry winter day in Chicago. Or notice your radio picking up extra cracker during a sunny afternoon in Los Angeles. Remember, that's distant echo of the sunspread reaching on the way down to your everyday life. Space is not empty, it's filled with the bright star, and the invisible force quietly shapes entire worlds, reminding us that our sun is not a distant lantern but an active participant in the drama of the cosmos. And in the little moments of our daily routine across the Americas. When the solar wind finally reaches Earth after its long voyage, something truly extraordinary unfolds, especially near our planet, the magnetic poles. Have you ever scrolled through social media and seen those breathtaking photos of green and purple lights dancing across the sky, and asked yourself, how on earth does the sun create something so magical from millions of kilometers away? Or maybe you've wondered why the lights only appear near the Arctic or Antarctic, and what it would feel like to stand under them yourself. The answer is right in front of us. The solar wind meeting our atmosphere in a spectacular light show we call the aurora. Earth's magnetic field generated by the therming molten iron in its outer core acts like a powerful shield, deflecting most of the charged particles away into space. But at the poles, the fuel lights up. The fuel lies deep toward the surface, creating funnels where some particles can slip through as they plunge into the upper atmosphere, around 100 to 300 kilometers up. They collide with oxygen and nitrogen molecules. The collisions excite the atoms, forcing electrons into higher energy levels. When the electrons fall back down, they release energy as beautiful shimmering light. Oxygen atoms glow green or red, depending on altitude. Nitrogen produces vivid blues and purples. The result, the aurora borealis in the north and aurora australis in the south, dancing curtains, swirling spirals and pulsing waves of color that paint the night sky in ethereal hues. What looks like pure magic is actually exquisite physics in action. During intense solar storms, the displace can stretch toward the equator, visible even in places like Florida, Texas, or northern Mexico. Just last year, during a powerful geomagnetic storm in May 2024, people in New York, Chicago, and Denver shared photos. A faint red glows on the horizon, rare but real proof that the sun's reach extends even to our temperate skies. Ancient cultures saw them as messages from the gods, vibrating dragon in legends, spirits, earth ancestors dancing in Inuit stories, are bridges to other realms in Norse myths. Today we taste them with cameras and drones, marveling at their beauty while understanding their science. Tourists in Alaska or northern Canada plan entire vacations around aurora hunting, staying up all night in freezing temperatures to catch a glimpse that the same particles that create that wonder are the very ones one we protect ourselves from the everyday with our planet's invisible shield. But more importantly, auroras are a visible reminder of something profound and invisible. Earth is constantly interacting with the sun, even from 150 million kilometers away. We are never truly separate. The sun's particles touch our atmosphere every day, and occasionally they put on a show that connects Earth directly to the heart of our star. So if you ever get the chance to see one, even a faint glow from your balcony during a strong solar event, pause and look up. You're watching the solar wind come alive right above you, turning the invisible into something you can feel in your soul. Not every planet orbiting our sun is as fortunate as Earth. In fact, most are not. Venus is Earth's hottest internal, with surface temperatures hot enough to melt lead. Mercury is scorched by day and frozen by night. The gas giants are storms of hydrogen and helium with no solid surface, and the outer ice worse. I looked in internal water. Earth sits in what scientists call the Goldilocks zone or habitable zone, a narrow orbital band where temperatures allow liquid water to exist stably on the surface. Too close and water boils away into spaces as happened on Venus. Too far and it freezes solid as on Mars. But distance alone is not enough to guarantee life. Earth possesses something rare and precious, a strong global magnetic field and a thick protective atmosphere.